Hi teacher, we are the nine group. We are Nicole Larisa, Juanita Contreras, Camilo Buitrago, Nicolas Calvo, and me, Manuel Castro. We are going to explain about everything about energy, nuclear energy. Okay, so basically the nuclear energy is the energy obtained by manipulation the internal structure of atoms, usually useful to produce electricity, although it can also be applied in other sectors such as medical, environment, or military applications. It can be obtained in two ways: by nuclear fusion and by nuclear fission. In nuclear fusion, energy is released when atoms combine or fuse with each other to form a large atom. This is how the sun produces energy, and currently this produce is not practicable despite being in the process of development. In nuclear fission, atoms break apart to form smaller atoms, releasing energy. Nuclear power plants use this technique to produce electricity. When one of these two physical reactions occurs, the atoms experience a slight loss of mass, which is converted into a large amount of heat energy, as the scientist Albert Einstein discovered with his famous equation E equal mc squared. So the principal characteristic is is obtaining generalized radioactive waste hard to degrade and very harmful. Some of the full processing reduce have a high application as in nuclear medicine, radiology, even in high power nuclear weapons. These herbicides are known as gamma rays, beta radiopharmaceuticals. However, these industries, such as nuclear medicine, are also guilty of nuclear waste with a high impact on humans. On the other hand, high-level waste in waste with a concentration of radionuclides such that thermal generation must be taken into account during storage and disposal. This type of waste is obtained in mining power plant. Is It is removed from the reactor to be temporarily stored in a pool of water built of concentrate and stainless steel walls inside the plant to create a radiation barrier and prevent leaks. In addition, it's a matter of reducing the volume of this residue to the max through distillation, evaporation process, or even subject to a volume reduced by means of external pressure. That is, a volume reaction is applied to its maximum capacity by measuring physical and chemical change. It is not renewable, as the main fuel used in is found in nature as the metal known as uranium and the other metal of artificial origin such as plutonium. It is a fairly low percent of reduced once is it subject to the heat produced in the nuclear reactor. The therefore is not renewable energy. Nuclear fusion or fission must occur for it or occur, that is, the union between two atoms, or to obtain a larger atom or division of it. How? The elements that are most used for this purpose are uranium and plutonium. As I mentioned before, the fuel most used in nuclear plants that are characterized by using the fission principle in the process. which are 19% of the nuclear power plants that exist today in the world, use those two elements. Is it an expensive source of energy due to the high standards of safety and technology necessary? In those nuclear power plants, safety equipment is used for both the plant's operators and the plant in general, since they are full of alarms and prevention elements such as neutron control bars are the same elements with which each reactor is manufactured at a high cost. All the technology behind a nuclear process is of extremely high value and an industrial level, since the software used for control and the same elements with which each reactor is manufactured at a high cost. All the technology behind a nuclear process is of extremely high value and an industrial level, since the software used for control and in case of emergency of the plant is quite complex for this reason, and moreover is its source of experienced energy.
Energy classification. This type of energy usually divides between nuclear energy produced by fusion and fission of molecules. The fusion is the union of hydrogen and its isotopes, which are deuterium and tritium, to form a new one that's heavier like helium. The fission is the reaction which the nucleus of a heavy compound is disintegrated by the capture of a neutron, and its division produces two lighter compounds, and the production of energy. The common element used to obtain this type of energy is the uranium, which energetic capacity of only one molecule is capable to sustain a car for longer than 78 years straight, according to the field. The classification in this classification, there are three ways to use this element. The natural uranium that is usually found in nature, such as soils, water, and geographic compositions. Mm, The enriched uranium where artificially they make an augment of the concentration approximately like 5% of the natural uranium. And the mixes where we can find plutonium and uranium in a form of oxides. According to the velocity, there are two types of reactors. The first one, the rapid or fast reactor, where they use a catalyst where the activation activity is decreased and the specification of pressure and temperature is lower than the thermic one. In the thermic reactor, we use the velocity produced by the increase of the temperature, and it's a lower reactor, but there are a lot of conditions that must be considered by the making of the reactor. According to the moderator of refrigerants, there are three classifications for the moderators: the heavy and light water reactors, the graphite reactors. For the refrigerant, there can be gas such as helium or carbonic anhydride, and water, light or heavy one. These materials can also make the function of a moderator of neutrons. And for the refrigerators, there can be gas also and anhydrous carbon. Another usual refrigerants are water, steam, molten sands, and molten metals.
The application of nuclear energy are very broad, but we are going to talk about the five most important. Energy production is the part of which nuclear energy the most exploited since it is a basic, very essential application today. We also find the application in industries, mainly in the use to verify the production process and know what errors can occur. The other hand, we have the military weapons. that in the story of humanity have been deeply and perfect. In the field of medicine, we will find the usage of nuclear energy is very important science in the will allow used to carry of diagnostic and treatment and disease. Finally, we have other applications, such as agriculture and the environment, when the fundamental is truth in the world. Energy production. A nuclear power plant has the objectives of transforming the internal energy of uranium atoms into electrical energy. This process like the following are field steps. At first, a nuclear reactor generates efficient reactions that emit a large amount of heat. With all this the thermal energy, high pressurized steam is the obtained. The steam tank to its heat pressurized drive the plant steam turbines. In this mechanical energy is obtained the energy in the rotation of the shaft. Finality, that version is shared of transformation mechanical energy into electrical energy in the electrical generator. In the non-renovator part, we refer to electric generation system using non-renewable energy of the system to use it full time to return on. In a section of nuclear power plant, they are thermal power plant to generate electricity. The thermal power plant, which uses coal of the fossil fuels, also take advantage of the calorific power in the fuel generation by pressurization steam drive turbines of power electric generation again. And we will talk about fuel renovation energy. We refer to renovation energy to energy stored to come for integration stored on the solar energy. Industry application. Nuclear technology acquired great importance in the industry sector. Specification in the usage to improve of industrial process, measuring, automation, quality control of raw materials from industry process, quality control of mass-produced products, sterilization of single-use products, trace of radiation active substances that are introduced into certain industrial processes. This action makes it possible to detect the trajectory of the substances and of the radioactive emission. In the way it's possible to investigate various variables of the industrial process, flow rates, leakers, and other arms. Weapons. Two types of nuclear weapons can be distinguished depending on the role of nuclear energy. Those that of nuclear energy direct to generation a large explosion, such as the atomic bomb, Hiroshima and Nagasaki. Thus, that the using energy nuclear as source of the energy for propulsion, for example, nuclear submarines of aircraft carriers, etc. Through the story, we have realized the great scope that these weapons have and the damage they generate to humanity, for which reason it is important to make correct uses of nuclear energy. Medicine. The application is nuclear medicine is defined as the duration of medical the use of radioactive isotopes, nuclear radiation, electric the field of action including the following aspects. Prevention. In the aspect nuclear medicine application, the callings of technology that are specific to hygiene, prophylactic and preventive medicine of the radiological project. Rational. Nuclear medicine is the default in the basic and the ampler range, using reactive isotopes and relative biophysical technology. Diagnostic. Its fundamental includes the performance of functional analysis, morphologic dynamic morphology, and the analytic tests. basic of biometric signaling and particle signaling principles and make aggregate vectors will now understand of the structure of fusion, the human body and the stark heat of disease. Therapeutics, in addition of important impact the nuclear energy diagnostic technologies have of the characteristics of management of patients. This especially include in the field of action some specific trumpet therapeutic indication of components of the atomic nuclear of relative biosciences technology of the prevention diagnostic therapies and medical research. The other application of nuclear energy. In this part we can find applications such as improve the greenhouse effect problems, improve the problem of surface and groundwater pollution, solve pollution problems, eradication of insect pests, genetic modification of foods. These very important sciences, with the science advance and the wind energy nuclear projects has been made in the field agriculture, thus allow more crops the very quality. We also find isotopes hydrology than also in the now the bearer of water and the helps to establishing the basis for rational uses. The main used isotopes are dating to know the age and the transit to time of waters.
Inside water reactor, the most used in the world. The fuel is uranium-235 and moderator is water or graphite. These reactors are usually composed three circuits that strike the heat. Each circuit have a steam generator. The first circuit, the fuel is inside the reactor, which relays the transferred heat to water, increasing its temperature by tubes that drives to evaporator, where it is water in low temperature, turning it steam. The second circuit, the steam passes through tubes that direct to turbines being exerted in a high speed and they are connected to alternators which make electrical energy. Uh, the third the third circuit, the steam loses energy and passes by condenser, which the most of the times are lake, river, or seawater. When it is condensate, go past to the evaporator one more time to complete the second circuit. Boiling water reactor. The refrigerant is water and fuel is uranium-235. The chain reaction produced by the nuclear fission is used to boil the water and that steam is introduced in the turbines who act the electrical generator. Then the steam loses energy and pass by a condenser where become in liquid water and recirculate it to the reactor impulsed by a bomb. Uranium gas and graphite reactor. The moderator is graphite and refrigerator is carbon dioxide and the fuel is natural uranium in metal shape. It takes advantage of the steam produced by fission reaction, but its fuel is introduced into tubes of material called magnets. Advanced gas reactor fuel is enriched uranium oxide, the moderator is graphite, and refrigerant is carbon dioxide. The fuel is introduced into stainless steel tubes. The carbon dioxide relays the core at high temperatures, generating water in boiler, thus completing a Rankine cycle to obtain energy. Mm, the gas-cooled reactor elevates temperatures. This reactor is evolution of the advanced gas reactor. Its difference First, use helium as refrigerant. Second, use ceramic and not metallic fuel. And third, less higher temperatures. Heavy water reactors. The fuel is natural uranium in oxide form. A moderator is heavy water and refrigerant is heavy water. The fuel is introduced in zirconium alloyed tubes and keeps the high pressure to hold liquids its moderator. Rapid breeder reactor. Its main characteristic is it doesn't have moderator and refrigerant is liquid sodium. Its fuel consists in two zones. First, fertile zones and second, enriched area. This in order to convert uranium into plutonium. It has two designs. First is loop and second is pull. Well, loop, the heat exchangers are outside the tank, and pull, its heat exchangers are inside the tank.
Okay, good afternoon, everybody. My name is Nicolas Calvo. I'm a petroleum and chemical engineer student. And for the last part of the presentation, we will be talking about all the laws involved in the nuclear energy sector. Okay. Before we start with the presentation, we have to delimit the presentation and what are the objectives and where we're going to go to. Okay. So we're going to talk about really quick about the organism involved in formulating and creating all these different laws for improving the energy sector, especially the nuclear. Okay. After that, we're going to talk about the national laws involved, the most important ones, because it's a really big subject. And we're going to end up with the last one, the international laws. Okay. With that being said, let's get started into business. First of all, we're going to talk about the organism. The organism involved in creating, formulating, improving, and all these policies involved in the nuclear energy sector. And its name is the Ministry of Mines and Energy. Okay, this ministry works with the currently government right now to getting the best laws possible. Right, the best laws they could improve with the companies and with the government. All right, they also formulate the most important, the safety and all this. With that being said, let's get into talking the most important resolutions involved in the national law of Colombia. First of all, is the protection and security. This resolution is the 18-1434 of 2002. This resolution was created based upon the Constitution of Colombia, which is based upon the environment and the safety of the Colombian people. Okay, so pretty much this resolution talks about all the natural and juridical people involved in the nuclear energy sector. What are the minimum requirements so they can work upon this industry? The second resolution, most important, is the categorization. This is the resolution 180052 of January 21 of 2008. This resolution, how it's saying, is the categorization of the damage of those radioactive materials can cause upon human health. Right? Not all the radioactive materials can cause the same damage. Some are more dangerous, some are medium, and some are they can cause minimum damage. Okay, so pretty much this resolution talks about all the lists and how they're categorized these materials upon their damage. Okay, they can do. For the third one is the authorized and inspections. This is the resolution 874 of 11 of August of 2014. As you know, all chemical engineers, not only chemical engineers, mechanical and all engineers and all industry, they have to go through some inspections based upon the ministry involved in that sector. For example, in our case, in nuclear energy, is the Ministry of Mines and Energy, as I was saying. Those are the ones involved to do all the inspections of the equipment, documents, and all the different aspects they have to go so the process is done correctly, right? Not only they can do that, maybe they don't have the time on all this, and they can pay a third party so they could do it, all right? This third party could be anyone. They just need to be authorized by the Minister of Mines and Energy. So those inspections are really important for us and in the industry because they're the ones that allow us to work. All right, they're the ones that allows to the process to keep going. Yeah, and they don't go to close. They don't close it and end up in a bad process. Okay, the next one is the resolution that talks about the management of radioactive waste. This resolution is the 180.005 of January 5th of 2010. As you know, the industry of nuclear energy, it goes back and forth as a saying of it's clean, but not really. I mean, like you could generate clean energy, but the waste they're making is not as good for the environment. With that being said, the management of radioactive waste is one of the most important things in this industry. For that, the government gives you a process and all the different documentation that have to go through it, that you have to follow to keep the process as much as friendly with the environment. All right. The next resolution is the resolution that talks about the regulation for nuclear installations. This resolution is the 1814/75. And this resolution talks about pretty much all the things, all the licenses that you have to go through it as an engineer, supervisor, all right, and as an operator. Yeah, all the identification that you have to follow in these nuclear installations, the time that um, that you are authorized to work on these installations. Right, you're not gonna be unlimited. Most of the time, is 2 to 5 years. It is based upon. It depends pretty much on the contract and different things. But pretty much it talks about all the process that you have to go through it for the nuclear installations to get all the equipment, the process that you have to go to get authorized by the government for your nuclear installation in Colombia. And after that, we have our last resolution, and this one is based upon the regulation for transporting radioactive materials. This is the resolution 1816/82 of December 9 of 2005. As you know, one of the most important things is how we're going to transport our materials, right? Our prime material is going to be by water, is going to be by air, is going to be by I don't know, trucks. It depends, all right? And not only depends the way you're going to be transported, but also the people involved with that. This resolution talks about all people involved in the transporting process, what process they have to follow, what procedures they have to follow for the safety of them and the environment. All right. All right. After that, we're going to talk about the international law. The international law, if you're an engineer that you're going to work I don't know, in another country that is not in Colombia, but let's say United States, Germany, Japan, France, I don't know, Russia. Um, these different countries have their unique laws, all right? But all of them, as Colombia, are, let's say, not like recommend, but they're like they follow the procedures of this organism that you're seeing right now. This organism is the International Atomic Energy Agency, all right? And what does this organism do, or what it is about? First of all, it was created with the United Nations after the World War II, and what we could see what the nuclear energy could do, all right, with the nuclear weapons, especially in Hiroshima and all that. These two institutions work like brother and sister, And this organism, the International Atomic Energy Agency, gives monthly reports to the United Nations with the countries that are using nuclear energy and how they're using it. Are they using it safety, for technology purposes, for science purposes, or are they using it for developing nuclear weapons? Right. As you can see, this process cause conflicts or geopolitical crisis of the United States, North Korea, Iran, Iraq, etc. With that being said, uh, this organism, it has a mission and activities. All right, the main purpose of their mission and activities is first the safeguards and verification of the process they're using the nuclear energy. All right, how how their process is verified. All right, all the inspections, all if they're authorized, and all of that. The second one is the safety and security. This is one of the most important mission. This is because of what happened with Chernobyl and what happened with Fukushima, right? It was not too long ago, and all the procedures for the control of the process. See? So you could bring that security and safety, not for the co-workers and the workers of the plant, but also the environment surrounding the plant and also the public, also the people, right? Because I don't know, a town may be close to them. And for the last mission is the science and technology, all right? As his name says, it's pretty much they're in charge of seeing and verifying if they're using it for the science and technology purposes. Yeah, they're most importantly for that. One of the things where the all the countries are based upon their laws upon is the Handbook on Nuclear Law. This handbook has pretty much 15 chapters, but the most important one, as of right now, as for you to know, is the 1.4, the principles of nuclear law. This one talks about all the principles that you have to go to the nuclear law. Let's say all the process for the licenses, for the installation, and different things. All right. But the most important is the 1.4.5. That is the continuous control principle. That's pretty much all the process and procedures you have to go to control the process of the nuclear installation. This is really important, as I was saying before, because of the accidents that already happened and that had been then all the damage that it has been done, all right, and it cannot be repaired. Okay, and that'll be pretty much all what I have to with the presentation. And thank you pretty much for your attention and everything. Thank you.